Okay, we're going to finish the notes that we started yesterday. Again, I'm sorry I can't be there or be here. I'm at jury duty, yay. Okay, so we went over our pressure. We did a pressure conversion. We converted one unit to another, making sure units cancel out, okay? You're going to do some practice with that after we finish the other quadrants, okay? And we also talked about the barometer and how, right, the air pushes down on it and can push the liquid mercury up and we can record it, okay? The last thing that you shouldn't forget about pressure is how it's created, right? And those are, right, collisions, with the walls of the, container. Sorry, that looks like an H. The walls of the container. Okay, so every time they collide, right, that collision with the wall of their container creates pressure, right, a forced area. All right, our next unit that we are going to look at is going to be our volume. So I'm going to move up here in this left side, go volume. And again, right, we want to be familiar with these units so that when you are reading a problem, you can identify these variables. All right, so for our volume, I'm going to actually zoom in. You can see what I'm writing. It is a measure of the amount of space measure the amount of space that the gas occupies or takes up. So if we have a container that's 5 liters, right, we're assuming that gas is 5 liters because they fill their containers, okay? So your units that we're going to be using for volume, and you know these units already, are milliliters from unit 1, our metric unit, milliliters, or liters. Okay, and don't forget, right, what unit is bigger, and this can be flipped depending on how you need it, but in 1 liter there is always 1,000 mils. Okay, this can be flipped, it can be 1 over liters, 1 liter over 1,000 mils, it just depends on what that question, if you have to convert it, okay? All right, volume also we know it depends on the temperature. Right, and you did this last night for homework, okay? If that temperature increases, the volume is also going to increase, right? Especially if we're trying to keep those collisions constant. All right, and the second one, right, volume also depends on pressure. This was the one you needed to do on your own, okay? And thinking about it, if that space gets bigger, right, those particles are going to have more room to move around, okay? So as the volume increases, your pressure should actually go down, right? There's going to be less collisions because there is more space. All right, and then the last thing, right, also that affects it is number of particles. For in a flexible container, we add more particles, that space is going to get bigger. All right, last one, and then we are done with this and we can practice some conversions, okay? And go to the right-hand side. And these will be up here if you need to, if you missed something, okay? temperature denoted by T. Okay. Important for this unit with temperature, and only this first part with our gases, that all temps must be in Kelvin. Super, super important. Okay. Also something specific about the Kelvin scale, right? It's just like another unit, like Celsius and Fahrenheit. This Kelvin value can never be negative. Okay, that's impossible. Why? The lowest temp in Kelvin is 0 Kelvin. Okay, this is referred to as absolute 0. And this is where there's no particle movement at all. Everything stops. Okay, so more importantly, you'll never have to convert Celsius to Fahrenheit, but you will need to get that Celsius into Kelvin. So how do you do that? Okay, it's very simple. It's not any unit conversions like pressure. All you do is Kelvin equals your degrees Celsius plus 273. Nice, huh? That's it. Okay, so if you have an example, you're going to have to do this in a second right after this. We have 24 degrees Celsius and we want to get it into Kelvin. All we do is plug it in. Kelvin equals 24 degrees Celsius plus 273. So we end up with 297 Kelvin. So when we start plugging into gas laws, you have to have your temperature units in Kelvin. Okay, and the last thing about temperature, remember, that temperature is a measure of average kinetic energy. Okay, an average. Okay, so what you're going to do right now is we are going to practice converting. Okay, so Mrs. Parker is going to give you a worksheet. You are going to do that right next to these notes on page 24. Nope, just kidding. 24 is used on page 26. Okay. So let me grab that really quick and we'll practice. I'll go through a couple with you.